Thank you very much for having me along. It's my pleasure to be here. Thank you, Mark. I was just thinking today, you and I have known each other for 10 years. It's
It
quite
feels a lot
something,
longer
isn't
though,
it?
doesn't it?
It's my pleasure to be here and thank you for having me. And thank you for still talking to me after all this time because I know I'm a bit of an acquired taste. A bit like
No, not.
a bit like the credible Hulk that you can see here. This is me when I get angry, and you wouldn't like me when I'm angry because I always back up my rage with facts and documented sources. So I'm a data person and I love data. I am that person, and I love this slide. I'm going to show it forever because it just makes me laugh. I hope it does you too. So the idea is we're going to talk about Azure Machine Learning today. I want to give you a quick introduction to the designer. It's been updated, and then I want to take you through some of the Azure Machine Learning SDK for Python. So let's get started. So machine learning is everywhere, and what we do find is people don't always understand what it means. So machine learning is basically more statistical methodology about how do you narrow down a search space to get a result. So artificial intelligence, on the other hand, is more about human-inspired thinking and how we can inspire human-like thinking into computers. So machine learning is much more about statistics, but they are both used for prediction. So just to clear up some of the terminology, because people get really passionate about artificial intelligence and machine learning, and we sometimes get a bit spooked when we go onto Amazon or Google and it suddenly brings back something that we were just about to search for. It means we are becoming easier to predict, and one reason for that is lots of data, and the other one is because the algorithms are getting smarter. But for many organisations, how do they actually get started with machine learning? And people often find they don't understand what it is, but they seem to have almost a FOMO about it. Everyone else is doing it, so I should as well. And machine learning is, as we see here, a good definition, the science of making computers act without being unambiguously programmed. So we're trying to reduce that search space by allowing them to use heuristics and use cases in order to learn. So an example of that might be before the virus actually driving to work. There are probably plenty of ways that you could drive to your office. And what you do is you tend to try and find the best route so that you can get there as quickly as possible, but as safely as possible as well, and preferably without getting any sort of speeding ticket. So machine learning is similar in that it's also thinking about these decisions. So nothing is ever certain. And there are lots of different possible solutions. And as humans, we are good at that. And machine learning is looking at trying to solve the same problems, but with machine learning. So we're going to look at Azure Machine Learning. It's a fully managed cloud service, so it's based in Azure, Microsoft Azure, and it's a low-code stroke no-code solution to help organizations get on board really quickly with machine learning. We note that here that it is browser-based, so you don't need to install any software on your laptop. You just need basically a browser, internet access, and a credit card, and off you go. So you pay for what you use, and there are different pricing levels for Azure Machine Learning. There are two main packages. One is Basic, the other is Enterprise. I never remember the prices, so you would need to head over to the website to see those. So you don't have to buy any hardware or software. It means you can use it when you need it. And it works for batch processing and also for real-time processing as well. So where does machine learning sit? Now, there are plenty of different ways that we can think about implementing a machine learning model. So the first idea here is to think about what business problem is it you're trying to solve. Remember that Azure Machine Learning is a low-code, no-code solution, so that means businesses are more likely to use that as a starting point, rather than jumping straight into Apache Spark and thinking about writing their own code, a very complex effort, straight away. So with Azure Machine Learning in particular, it's more like a fast fail type of project or a fail-safe type project where you can get started quite quickly in the cloud. And if it doesn't work, that's okay. You can just delete it and start again. And that's what organizations tend to want when they are thinking about playing around with this type of technology. It feels risky, but once they get onboarded, there are plenty of ways they can get started really quickly. So the first thing is to understand that machine learning is capable of producing the right answers to the wrong questions. So that means that sometimes people think machine learning or AI is going to be some sort of panacea that's going to save your business during the COVID virus, it's going to cure cancer, it's going to do all sorts of activities like that. It's going to help cure COVID. But the reality is sometimes the scope gets too high and gets too big. So these projects can often fall by the midway because expectations are not managed and people get a bit inspired by watching films like Terminator where we think about this machine that can do everything and even take over the world. But we have to think very carefully about the business question and what is it we're trying to achieve. So these projects can be often very difficult to manage, and welcome to my life because that's what I do. Implement and try to get them over the over the finish line so they are successful. Now, data understanding is an important part of any project, I would say, not just machine learning, but also business intelligence as well. We have to think about collecting the initial data, understanding it, exploring it, and then seeing what we can do in order to improve the data quality. Now, it's very much the case that if you have bad data quality, anything that rests on it will be bad because you're not building your algorithms on a solid foundation. And until you do that, you can't be confident of the veracity of your algorithms. So if your data is incorrect or you have lots of problems with it, you need to sit and work out a way to get the data so that it's good enough to be used for models. It also makes it more difficult to troubleshoot and understand where problems are coming from if you don't get the data in place first. And there's many different ways that you can actually think about data. So here's a great example. I love this example. It depends who's asking the question, but even a simple question like 9 plus 10 gives you a different answer. So here we have the answers 910, and then somebody has put those together as a string, 9 and 10. So now they're no longer integers, but they're a string. And we say then we found the programmer, and then finally let's string them up. So I think I have a terrible sense of humour, but I thought it was really funny. So once we've thought about different ways that we can think about our data, whether it's a string, an integer, how it's even calculated, we need to try and think about how we can solve those issues. So we talk a lot about data literacy, but in a way that's a bit insulting to business users, as if we are assuming that they are illiterate in some way. The reality is we live in a world where we are surrounded by data. We have lots of data, too much data. We also have a ton of information. We have some knowledge, and we have even fewer amounts of wisdom and even less judgment. So with these sort of issues, what we can find is data preparation will set you up, but we need to sort out the data so we can funnel it down. So we can turn it from data to information, then turn it into knowledge and hopefully into some wisdom. Being data-driven isn't enough. We need insights as well. And those insights can come from wisdom, a good starting point. So we need to think about modeling and Azure machine learning as well. Now this is one of the things that people find most confusing about Azure machine learning. If you have a Bing search for Azure ML cheat sheet, what you find is there's a cheat sheet of all the models that are available in Azure machine learning. So what I'll do is I'll then show here, there's a few more slides to go, but we can come through that. And I'll show you where the Azure ML cheat sheet is. So if you have not looked at the Azure Machine Learning cheat sheet, I recommend that you do. You can see a copy of it here. I'll see if oh, that looks like an old version. There's a later version than that. Here it is. We'll try this one. So what you can see here in this cheat sheet, I will just scroll back up a little bit. There we go. It all starts with a business question. What do you want to do? Now that's often harder for people to answer than they might like. Often they'll say things like, give me all the data and I'll figure it out for myself. And that might be translated into something like, export the data to Excel in a CSV file and I'll take a look. And I want the data for the last 5 years in some sort of CSV file dump. When that happens, what they are trying to do is tell you, I don't really know what I'm looking for. So I'm going to play around with the data till I find something. So they need to think about better articulating and then prioritizing what it is that they want to do. That doesn't mean that they can't change their mind afterwards. It just means you're keeping a note of all of the expectations that you're going to have to manage in order to make your project successful. So I've highlighted a few items in red, and I hope you can see them. So with many projects, what we want to do is try to predict values. I'm working on a project on an ad hoc basis in which we are trying to do exactly that. So when we look at predicting values, it means that we had some other options we could do. So we could predict values, and that would be basically looking at the metrics that you might find in a facts table. The other thing we could do is look at predicting between categories. So that's more looking at your dimensions. If you're coming at it from the business intelligence angle, that's what we're trying to do. So if you haven't seen the cheat sheet, I recommend that you have a good look at it. So now let's get stuck into Azure Machine Learning. So I've already set up an Azure Machine Learning portal here previously, and I did that in order just to try and speed things up a bit. If you want to create one yourself, you need an Azure account obviously, and then you just go to the top right hand side, and then you select the option to create a resource. And then in the search box, you type for machine learning, you enter in a few details, and then you are hot to trot, basically, you're good to go. So here we can see this particular example. I've called it Hybrid VG, Hybrid Virtual Group, and then tagged Azure ML on the end. So here we've got, I am using the Workspace Edition here. And the reason I'm using the Workspace Edition is because I want to show you the graphical user interface that will help you to design your experiments. In the Azure Machine Learning terminology, we call our processing experiments. So basically end-to-end processing of our data using a model in order to get results. So what you see is a few chats. Oh yeah, that's great, thank you. So what you see here is that the Azure Machine Learning Studio is where we can actually design our machine learning experiment. And to do that, we click on the Launch Now button, and that produces the Azure Machine Learning Studio here. I'll take you on a whiz tour around the Machine Learning Studio. We'll have a look at creating a quick experiment, and then I'll show you how we can access notebooks in the Azure Machine Learning SDK for Python, all through this interface. So when you create your Azure Machine Learning outfit scenario here, you can see that it lands you in the studio, and there's a few options available to you in terms of tutorial. Now, we're not going to cover AutoML in this session. Maybe that's something we can do at another time. But AutoML is specifically designed to help you to identify which model would be the best fit for your data. These are very high level. Under the hood, Azure Machine Learning SDK for Python uses, and the AutoML functionality that we see here is using scikit-learn, which is one of the Python models. One of the Python libraries. And it has available over 100 models. And what AutoML will do, it will use a sample of your data, and it will process it against a number of models that you specify, and then it will make a recommendation to you based on a number of metrics, such as the area under curve metric. So that's what the home looks like. One place that you may start off in would be the designer. So here is the designer, and we can create a new pipeline, which is basically all of the modules in Azure Machine Learning, and we try to connect them all together, and we do that in order to make our experiment work. Earlier, I showed you the CRISP DM methodology, which we see here, and this methodology is about the business understanding, and then we have a few other modules about data understanding. So if you want to try and understand our data better, we can start to use a new pipeline and then use some of the modules in here in order to understand our data better. So one thing it's going to ask is it's going to ask us to create a compute target. So it says I don't have one here, so I'm going to create a new one. And I'm going to give it a name. I'm going to call it Azure Compute or ML. Then I'm going to save that. Now it's going to create a compute target for us. Now what that's going to do is it's going to create a compute target, which is basically going to be the engine that's going to run our experiment. So that's what the compute target is for. So we can select a pipeline. This one is probably still provisioning. It's in the process of being created. Now on the left-hand side, you may notice that there's a compute feature here. So let's take a look and have a quick look and see how that looks. So we can see here, I already have a compute. For some reason it didn't pick that up. So I'm going to refresh that and hopefully we can see our second compute running. If not, we'll just leave that running. So there's one thing to notice, that due to the virus, Microsoft are maintaining service availability in Azure for key workers who need it. So if you do try and create an Azure machine learning resource and it doesn't work or it says it's not available in that region, please do try one of the other regions. In that way, you'll probably find that one of the other regions will allow you to set up the Azure machine learning for you. Okay, so I'm going to go back to the experiment that I was just creating. Select compute target. So I'm going to select this one and save. So now we can see my compute target appears in my settings. And basically you could have different compute targets dependent on various factors such as the power of your compute target. You may decide that you want to develop in a smaller compute target and then as you move along deploy to different compute targets. So that's just one way of varying the power and amending the cost in your experiments as you go along. So the way that Azure Machine Learning works is that you drag and drop lots of modules together. So I've got a small data set here, which is the adult census income binary dataset. Now we do like to give credit where credit's due, so I will show you where that is. It's in the UCI adult dataset. And if you want to play around with this dataset, you can get access to that here, and you can see the dataset description, for example. Now this dataset is available for prediction. Oops, I don't know why it's where, but there we are. So you can see here the dataset description and the abstract. The idea here of this dataset is to try to predict whether the income exceeds or is less than 50,000 a year based on census data. And you can see what the columns actually mean when we look at the dataset names. So if we go into the data folder, you can see the dataset names here. Oops, keeps trying to do that. So in fact, if you go down to the bottom of the page, I'm sure that it appears there, yes. So here's the column names. Now the one that we are trying to predict is we're trying to understand whether that person earns above or below 50,000 a year. So we can see a number of the columns are specified here. Okay, so that's the machine learning data we're going to use in this experiment. It appears in Azure Machine Learning. So we've got our data set. We've had a look at the descriptive information about it. But what does that actually mean? So what we can do is that you can click on this and we see some outputs here. And on the right hand side, this is going to tell us a little something about our data. So to get this to work, you must click on the module, then click on Dataset Output, and there's the option to visualize. This will help us to understand the data better. So we can click on age, for example. And this will give us some descriptive statistics about age. What you can see here is that some of the people in the census dataset are showing as between 82 and 90 years old. So they're fairly elderly. Now that tells us that something is wrong with the data because ideally somebody of that age range should not be working. So that tells me something is wrong with the data from the practical level. So we can also see the number of years that people have been in education for, and we can also identify how many are male, how many are female, and we can see we have a bit of an imbalanced data set, many more males than females. We can also see country as well. So the vast majority from the United States, and we have some from England, just a tiny amount just there. And then we've got the income column, and this is the thing that we are interested in trying to predict. This identifies whether people are earning above or below $50,000 a year. So that gives us some idea about the data, but we can dig in even further. There's a module in here called Summarize Data, and I'm going to connect these modules together. The way that we do that is, hopefully you can see that tiny little bobble just in there. That's the output module. And I'm going to connect that to the Summarize Data module. So what this is going to do is it's going to provide more detailed information about the data set for adult census. So we can rename this pipeline, and I'm just going to call it Hybrid VG Adult Census Experiment. And that's it, it's got a better name now. So put together, that's actually specified. We can create pipelines here. So to do that, we can go to the designer. I've got my experiment name here, and now I'm going to submit this in order to run it. Now there's one reason I do this. One is because Azure Machine Learning needs to get the metadata of the data, and one reason we can get that, it's a pool of the data, is we can run an initial run. So the way that I look at it is it's gently, incrementally. We can get started by looking at the data by just taking steps as we go along. So all we're doing here is double checking that we can retrieve the data and we can do some querying on it. Basically, we want to understand the descriptive statistics better. And that shouldn't have a space. I am always doing that. I can never work out in Azure where the spaces are, whether I can use dashes or underscores. So that's my feeling, well, one of my many feelings. So we'll leave that there. We can see that it's running at the moment. I'm just going to move GoToMeetings, get a window over there. So I can view the overview of the run. I hope you can see that over at the right-hand side, so I can regard the progress of how this is going. So since this is the first time it's running, it may take some time to run. You can see the output and the logs are in here, and that allows you to see the logs as things are running. So far you may have noticed we have not written a single line of code. This is a low-code, no-code solution, and we can do things with this experiment that are way more complex than descriptive statistics. You can see there's a number of models here. So you can choose different types of models. You can see these machine learning algorithms. I'll just move this over a little touch. Oops. My mouse is, anyway, I thought I could move that over, but obviously I can't. So if you look in the cheat sheet, this gives you a list of all of the algorithms, and when you drag and drop them, you can see them over here as well. So we could drag in some more. So we could add in linear regression. That would just be a starting point. But what we'll do is our experiment is running, and it's not going to let me drag and drop or change anything while the experiment is running. So here's an idea. Why don't we go back and we will have a look at the compute that we saw earlier. Now, so let's park that experiment. It's running, so let's leave that one. While that's running, let's go back and have a look for Azure Machine Learning and the Azure ML SDK. So on your cluster, when you set that up, you can see you have a number of different options. You have Jupyter Lab, Jupyter, and RStudio. So for our purposes, we are going to dig around in the Jupyter Notebook, and that's how we can access the Azure ML SDK for Python. So what you can see here is a Jupyter Notebook, and that's created when you set up your notebook. So you can see here we've got an experiment, creates the first ML experiment. So I'm going to pop that here and we can take a look through that. Now, before we dive into that, you can actually set up more samples if you like. You can upload your own experiments by going into Notebook. And you can see here that under there's a folder called Samples, and there are plenty of samples in order to get you started. And you can see those here. When you open some of them, say we open this one, you can actually then deploy them and you can have them running on your compute target. So there's plenty of examples to use. Say, for example, you've got machine learning, taxi data one. So there's all sorts of different examples. So the one that we're going to look at is we are going to start looking at the very first one in order to get it started. So we can see that in this experiment here. So I'm going to run all these cells because sometimes they take a little bit to run. I'll let those run and then we will catch up with them. Okay, so in case you're not familiar with it, this is the Jupyter notebook. Now this is called literate programming. And what that means is that your code, your comments and your results are all in the same place. So here we have an example of some code. We are using the Python SDK, the Azure ML SDK for Python. And one of the key concepts in that, one of the key classes is the Azure ML core. If you're thinking of sitting the AI 100 exams, I recommend that you really learn, or the DP 100 exam, I recommend you have a look at the classes for the Azure ML core, and that will really help you to get a good grounding in the material that you need for the exam. Now you may have noticed something it's doing here. It's asking me to perform interactive authentication, so I'm going to have to do that. Into the code, and the code you can see is just over here. So I'm just going to pop that in the browser. Now it performs interactive authentication. You can set up Azure ML, so you don't need to do this. I have not done it. This is just a quick experiment, so there's no point. I would add that I'm not a security expert, so it's just not my area. I think I've seen so many organisations make themselves sick over security that it really just puts me off. I'm not brave enough. I leave it to the people that know what they're doing. So now that we should be able to continue here. So now I'm going to try and run this again. And now it says interactive authentication successfully completed. So that's all I wanted to know. So what this notebook is doing is it's going to load some data and run some code and output the results to the notebook. So that's so I'm just trying to move GoToMeeting. There we go. So what we can see here is it seems to be working so far, so that is good. We'll go through the code line by line. But the main thing to note at the moment is that we have a number of classes that we can use when we connect to the Azure Machine Learning. And we can connect to those and then run Python as well in our notebook. You can see the Python shell is being run at the top. The kernel details are here. Now, in case you're interested, in Jupyter you can actually change kernels as well. And you do that by changing the kernel in the menu. If you're using something like Databricks, you can actually change programming language between cells if you put a percentage sign in the top of the cell and then specify exactly which language you're going to use. So let's start the very first part. What we're going to do, and I'll run this so you can see it, this isn't going to output anything. But again, we are back to using Azure ML Core, and this time we are importing a class called Experiment. Now, interestingly enough, when we go back and look in our Azure Machine Learning Studio, we also have the concept of an experiment here. So we can see we've got two experiments. The hybrid VG is the one that I just set up, and I'm going to set up another experiment now. So this one I could delete that one. But it doesn't matter, we'll leave it running, we can overwrite that one. But the idea here is that regardless of whether you use the interface to create an experiment or you create an experiment here in the code, it means that you're interacting with the underlying Azure ML SDK service. And that means when you can do that, you can add some really interesting machine learning algorithms to your application or to your investigations when you're working with data. So I'm just going to run that piece of code here. So we've got a few things happening. The first thing we do is we are back using the Azure ML class again, and we are using open datasets. So that's one of the classes available. The last one we briefly discussed was Azure ML Core. Now, if we can't import any of the Azure ML classes, none of the rest of it's going to work. So that's why we start off doing that first. So here, what we're doing is we are importing a class called diabetes. And that is going to give us access to the diabetes dataset. And for this example, using Azure ML SDK for Python, we are going to make predictions based on the diabetes dataset. We're going to try and predict who has or who does not have diabetes. Now we also have a class here called model selection. Now this one's actually coming from Python. sklearn is scikit-learn, and that's one of the most popular libraries in Python that you will come across. And we're importing train test split. Now what that's going to do is it's going to help us to define a training set and a testing set. Now there's lots of different ways that you can set up your data as distinguish it from your training set from your test set. You could have a validation set as well, for example. The idea here is that we're sending a certain percentage of our data to be a test data set, which you see here is going to be 20%, and the rest will be part of a training data set. So then we can train the model. So I'm just going to run that, make sure that runs. So it's quite a simple piece of code. In fact, let me try that again. Hopefully that will work this time. I'll be embarrassed if it doesn't. Okay, so here we're going to train the model. And we're importing a bunch of libraries from sklearn, scikit-learn. And we're just going to set up and we're just going to run the model using just some sample data here. Now what it's going to do, it's going to output what's known as a pickle file. I may not be saying that right, I'm never sure if I am, but I only hear it discussed as a pickle file, and I've got used to calling it a pickle file. So basically that is the format that the Python script is going to come out in. And it's going to come out in a compressed format, and then we can re-upload it elsewhere if we decide to do that. So what this is going to do, is going to start running metrics about the experiment, and it's going to log those, and we can see that here. Then it's going to try and fit a model based on our diabetic data. And what it's going to do is it's going to take the training data set and it's going to try and predict, using the training data set, it's going to try and work out what the patterns are within the data. So we've got something interesting here, which is called Rmse, and that's root mean square deviation. And that's used to predict the differences between the predictions made by the model and the actual values observed. So the way that I envisage that is a bit like a dartboard. And that is really, say you're trying to hit the bullseye of the dartboard. And what the Rmse is going to give you is basically the distances between the location where the dart actually hit and the bullseye in the middle where what your target is. So it's basically going to sum up and give you the average of the actual and the predicted values. So what did it actually say versus what was it predicted to say? So that's called the root mean square error, and that's one of the many metrics that we use in order to understand better quantitative data. Okay, so that seems to have run. So we're going to give our model a name, and we're going to call it the model alpha, and then we're going to write out the model to a pickle file, and we're going to place it in the outputs folder, and we're going to give it, the script's name will be set to be that. So once that's done, everything's complete, and all we need to do is call experiment. And that's basically going to act like an estimator. It's going to give us everything, all the information, all in one place. That's going to give us a link to the experiment in the studio. Then the main takeaway point here is that what you do in the Azure Machine Learning SDK for Python, you can also see in the GUI as well. So we're looking at it from a situation where we have to write code. Now the Azure Machine Learning Studio allows you to have that low code stroke no code solution. But what we're doing here is we're looking at it from the code angle. There's a trajectory in data science often where you can start looking at the low code solutions and then onboard to the coding solutions. And let's have a look at how it looks in Azure Machine Learning. So to do that, I hope that wasn't too quick, but you can see the link to the report page is given here. So let's have a look at it in Azure Machine Learning. You can see here we've had a number of runs of this experiment. Got run up to 16 now. So we can see how that is progressing. You can see the compute target has been specified SDK, so that tells us that this has been run from a notebook rather than run from the GUI. It's taken 5 seconds to run, and you can see each of the runs here. So let's click on the top one. It tells us just in a quite nice GUI how many runs of the model have completed and how many are still running. So we still have one running here. So I'm going to click on this one for the latest run that we can see. And now we can see that run 16 is completed and we've got an Rmse value of 56. So the input datasets given is none because we didn't use any from the Azure Machine Learning. But you can see some of the metrics. So we can see Rmse, we can see the value there, we can see the alpha values set to 1. We can see any images are specified, so sometimes you can dump charts and graphs out when you do the experiment run, and you would see that here. You can have runs that kick off other runs, and if there's any child runs, you can see those specified here. So here's the pickle file. So if we want, we could download that file and then open it in an appropriate editor and see the Python file inside. We've got the explanations here. Now, this is still in preview. When I've tried to use it, it's good because it's about the explainability of the model. It's looking at the ethics. You know, how did they get to that result? So we haven't got anything here. I tend to find it takes a little while to get set up. So I've just left that. I'm not going to run that. So we can talk about ethics another day perhaps. It's certainly a very interesting topic. So let's go back to our Machine Learning Studio. And now we can see an image here. So this is just an image of the model, not our model. We have seen ours and how it looks in the Azure Machine Learning portal. So we can see they got the same results, Rmse, and it gets better with each iterative run of the model. So it fine-tunes the value. So we can see the run number as we've just done, and we've had a look at more detail. So now we can run this one. So what this can do is it can use scikit-learn in order to try and pick out which one is the best model. So we can try and, all right, I'm having some issues there. So I'm just going to leave that and we will go back to our original experiment in the designer. So this is the one with the adult census experiment. So hopefully that's run. And now we can see that our adults data has given us a quick summarized data, and we can see the outputs here, and we can see the results data set, and then we can visualize that. So this is going to give us the equivalent of summarize command in R. If you use that, it will give you the count, the min-max, and you can see some of these are not available because they're not a number. For where it is a metric, it's going to give you things like skewedness and kurtosis. that's applicable. Obviously that doesn't apply where it's been a text. And you can see the min and the max here. So when we look at age, for example, the minimum age is 17, but the maximum age is 90. So that tells me something's wrong with that data, with those lines of data, because we should not be finding the case that we have got 90-year-olds working. Certainly, I hope not. So we can start to make this model a bit more interesting. I'm just going to leave the summary just there. So what we can do is we can start to add in some interesting things to the data. So what we can do is I can clip these values, and I'm going to join these two together. So when I clip the values, basically that means I can try and work out what the threshold should be for age, for example, and I can cut out people who are in their 90s, column name equals age, and the constant value I should then put through, say, as 65. And then when I run this, next time it will give us a decreased number of rows because we'll have cut out anyone who's over the age of 65. So once we've clipped our values, what we can do then is we can start to think about transforming the data into a split. So we can use some of the data for training and some of the data for test. So to do that, I'm just going to type in split. And you can see the splits data module here. So I'm going to put the output from clip data and I'm going to connect that to split data here. So you can see here that the amount of data for splitting is 0.5. And for our purposes, we are going to use 70%. We're going to try and use that. So that means our data will be split into a training and a test data set. You see that the split data module has actually got two different modules. So there's a left output and a right output. Now the training dataset will always appear at the left-hand side, and the test dataset will always appear at the right-hand side. So what are we going to do with our training model? Well, I'm going to type in the word train, and I'm going to train a model, and we could use one of the regression algorithms. So here we've got an example. We could just use linear regression. So I'll just use that one. It's the simplest one. It's a good place to start. So for splitting the data, I need to connect up this to the training model. That goes here. And then I'm going to connect up this model. So linear regression is basically just a predictor. So split data is completing. Why is that completing? Yes, because it needs another module here. So I'm going to look for scoring the model. And what that's going to do is it's going to take the test data and connect it to the scored model. And then I'm going to put train model in here and connect that up as well. So when we, sorry, I can't see for that. So we're going to split the data. We've got linear regression here. So for training the model, it wants to know which value we want to use as a predictor. So I'm going to choose edit column and I'm going to choose income. And that should now help. So it doesn't like that split data. So the score model, once that is in place, what we can do then is add in another model for evaluate. Oops, if I could spell, that'd be amazing. Evaluate model, pop that down here. And that's going to tell us how well the model did. You can add in more than one evaluate model here. And what that's going to do is it's going to tell us the output. It can tell us how the models compare to each other. Okay. So just to summarize before I hit run, and then what I'll do is I'll open up the floor for any questions. We've got a number of models here, and we set this up using Azure Machine Learning. We've got our data. We've done a little bit of data preparation. We've clipped the values. There's more we could do in that data set. Then we split the data into a training data set and a test data set. We're going to use linear regression just to see how that looks like. And then we're going to evaluate the model at the end. So now I set up the pipeline run. And it's basically going to tie together the experiment. And it's also going to identify the compute target that we want to act as the engine for running the experiment. So I'm going to let that submit, and I'm going to double check the chat window to see if there are any questions. If you've got any questions, please do ask.
I've got a list of questions here, Jen.
Okay, good.
So, well, the first one I have is a personal one here, and it's, I think learning this type of stuff for me means playing around with it a lot, and I like the fact you've given us one data set to play with. Is there any, I mean, what's the best way to find data sets to play with for this kind of thing?
I actually really like the UCI one. I also like Kaggle. I love Kaggle just for data sets, just for samples. These are great for learning because you've got data sets people have submitted, but there's also lots of sample codes that people have submitted as well. So if people are looking for data sets, I recommend they have a look here. You can see there's lots of, you can start to look around and play around with people's codes and get things to work. I don't know how you learn, Mark. I learn by breaking stuff and then apologising. And if people are really lucky, I might sound like I mean it, because all I'm going to do is tear up a new virtual machine or a new Azure machine learning experiment, and I'm just going to start again. So my life is littered with failed, broken experiments in order to get stuff to work, because life is just like that. You know, I think when I speak to people who are sort of training themselves up in data science, they seem to expect there's a very linear path. You will do this and this and this, and then we're going to zoom away through it and we're going to get this magic number. And the magic number is going to be like a little God in a box. It's something we're going to touch and it's going to tell us what to do. And it just isn't like that. If people saw how miserable it can be sometimes to make sense of the numbers, because there's so many different data sets and there's so many different algorithms, that's the hard bit, and I think that's where the future lies, is being that analytics or data science translator, where you can take the numbers and turn them into a meaningful pattern that people can understand. So we're back into data visualization again of artificial intelligence.
Cool. Do you want all the questions now, or do you want just a few more?
Fire away, I don't mind.
Okay. Okay, so yeah, okay, so yeah, well, stop me when you do want me to shut up. So you did talk about sort of learning this stuff, and that leads me on to another good question, that can you recommend a good book out there to get started with machine learning and data science for idiots like me?
Well, first of all, you're not an idiot, and secondly, I've actually contributed to a book to machine learning, but I'm not going to tout that one because there are plenty of fantastic...
No, tout it. Go on, tout it. What's it called?
I can't remember.
That's why you weren't going to tout it.
That's the question. I know. I've forgotten what it's called. So
but
Packed Machine Learning.
Yeah, Packed. Yeah. Okay, cool.
All right. So I have to Google my own book title. That's miserable.
Yeah, that's not good at all.
No, it's not. I'm just going to go and jump out a window because I clearly have got no idea. I can't even remember. I've got a copy of this. In fact, I've got about 3.
Cool.
So anyway, I contributed a few chapters, and these people that are way cleverer than I am, contributed more. So that's one. The reason, well, I was really excited to be part of this process.
And I think that was recommended, wasn't it? It was one of the top 5 books for machine learning, wasn't it? If I remember correctly, from a tweet that you had. I'm sure.
I wouldn't remember that. I can't even remember the title of the book.
I was recommended a book myself, and I think this might have been Steph Locke who recommended it. And so I don't know if you're familiar with this one, Data Science for Business by Foster, Provost and Tom Fawcett. And the reason I like that book is it's not technology. In fact, it doesn't really talk about technology. It just really talks about how data science works, and I can't even think of any data science terms now, but I started reading the first few chapters and felt like I understood things. So I would give that one a thumbs up. I'm hoping hopefully I'll get my hands on your book sometime as well. Right, moving swiftly on. So I've had a little bit of experience with Azure Databricks, Where does the Azure ML Studio and Azure Databricks really fit in together in the analytics workspace? And I don't know if this is a valid question or not. When would you use one over the other?
So I would use Azure Machine Learning for that low-code solution where somebody's just onboarding with machine learning, perhaps never used it before. So you can see the experiment I've done here was no coding. I've just clicked stuff together and somehow managed to nail together an experiment without coding anything. So that's a good place to start. It's good just to understand those concepts, and that helps just to tie everything together. People can think about coding later. So if you want to roll your own code, then Azure Databricks is really good for that. So it's got, as you know, Mark, Spark lying underneath it. It's got Spark Core. Now Databricks specifically is optimized. It can run loads somewhere between 10 and 100 times faster because it's especially optimized for delivering that Apache Spark workloads so much faster. So it's one of these things. You could start up Apache Spark and just use that because it's open source, but it would take you longer to do it and it would take you time to try and put all these pieces together. So I like Databricks as well because I can use different languages in it. So with that, I can use Scala, I can use R, and I can use Python. We have R and Python in here, but these are just more early in the trajectory, so they're not quite as advanced. You can add in your scripts here, but it won't output a model. It will output a pickle file, which is exactly what we saw in the experiment here, the outputs. So to summarise, Databricks, I think, is great for enterprise solutions where you've got a team of data scientists and it can take in streaming data, it can deal with the Lambda architecture very well, so it can deal very well with the real-time speed layer, it can deal very well with the batch layer, and then put those together on the serving layer.
Cool. So this next question, I don't know if this is me being stupid or not, but I was a little bit confused as to the use of Jupyter notebooks and the experiment. So did I understand it correctly that the reason you'd be using Jupyter notebooks in this scenario, the integrated Jupyter notebooks, is to just play around with the data and the experiments are for the actual things that you want to automate? Is that correct, or did I not understand correctly?
Well, actually, yeah, we didn't get time to get through the end piece, as it were. But what you can do is you can use Jupyter Notebooks to create and deploy your model using the Azure ML as a service, basically, and you interact with it using the SDK.
Right,
so you could do it that way, or you could use Azure ML to do that. If you've only got the Azure ML Basic Edition, I've got Enterprise here. I don't know if it tells you in here. It's telling me here, actually, yeah. So when I go in, I've got the Enterprise Edition. So if you've only got the basic edition, you won't have the GUI that I just showed you. So you won't get any of this sort of big blue buttons or anything. But what you would have to do is you'd have to use the notebook and you would have to use compute to set up notebooks. And you could only interact with it that way. Whereas with Azure Machine Learning, if you want to use a graphical user interface, then you need to use Enterprise. But there's a whole load of different SDK. It has a lot of classes and different functionality for deploying these models to production and interacting with all of the information. Actually, I'll show you a great resource for that. So the GitHub DP100. So I'll give you the URL for this in the chat window.
Cool.
If you're interested in learning more about the SDK specifically, running through this code is really, really helpful. So you can see some of the loads down here. So you can actually use the Azure Machine Learning SDK in order to really fine-tune how the model looks. And so you can do all sorts of things just to get it up and running. So here's an example of publishing the pipeline. So you could do it using the code, or you could do it using the Machine Learning Studio interface. I think the code is better if you prefer scripting. But as I say, it depends what the skill set is in the workplace environment. See, we can publish that. We can set that up as a REST interface. So that's going to help us set up the REST endpoint. And then that will help set up the web service just so that it all runs, really. We can
Great
schedule
stuff.
the pipelines as well. And again, it's all coming down to that Azure ML class. This time we're using Azure ML Pipeline Core, and we start to import a few of the classes in here. So
Okay.
yeah, you can do all sorts of things. It depends what your requirements are, really.
Cool. I don't know if you're going to be able to answer this one or not, because you're Mrs. Moneybags and you're not bothered about cost, but do you know,
Oh, if only that were true.
yeah, that's why I was chuckling, because I know we're both not. So do you know, my understanding is there's no cost associated with Azure ML. Is that really true? And what happens if you're churning through loads of data?
Oh, I've no idea. Let's have a look from what Azure ML price costs. I don't know.
I think the
I'm an
last time I looked,
MCT,
yeah, I think the
so
last
I'm an
time I looked,
MCT,
it
so I get
wasn't.
some for free. Let's see. So being a Microsoft certified trainer, I get a certain allocation of Azure for my training, so I don't look at the costs other than switch everything off as soon as I've set it up. So the minute this webinar
Yeah.
ends, I'll be deleting that resource group because I'm stingy. So there we go. We've got pricing, basic and enterprise. So you can see there the basic has got very little in it. You have to use the SDK to interact with it.
So I wonder, because I wasn't even aware there was two different offerings, so I wonder whether the enterprise has come along in the last 12 months, because I don't know, I somehow missed it. Okay.
Yeah, it just seemed to sit in preview for a very long time. I do remember that.
Oh, what? Enterprise, £0 per core per hour. That's interesting.
Yeah, it's from, isn't it? So let's say enterprise East religion display pricing by. Oh, I need to play around with that. All right, so here's all the prices down here. So the Linux pre-M, so less than a penny an hour.
It's pretty good though, isn't it?
Yeah, it says I didn't realise it was that cheap.
And Databricks cost quite a lot of money, so this is quite impressive.
Yes. I always get my customer to set up Databricks for me using their account and then give me access. I'm not paying for that.
So another question, which may be a silly question, but maybe it's not. So if you've got lots of different experiments, could you kind of chain them all together, run them all together in some kind of workflow, you know, using something like Azure Data Factory, or would that requirement never happen?
Yeah, well, the idea is you could chain pipelines together if you wanted to do that. So I'm just thinking, yeah, so here's experiments. So you can set up different experiments in here and then chain the runs together. So I'm trying to think, I don't have an example, I don't think. No, I don't have an example in this one because it's just a new one. But I had an example where you have a run and, excuse me, sorry, and it kicks off a whole load of other child runs.
Yeah.
There is an example of that in the gallery somewhere. So you can do it that way. So that's, I don't have that as example here, but I did have that before and I've probably deleted it. I'm sorry.
That's fine. So doing that though would be more within ML that you're creating those run pipelines, is it, rather than doing yet another Azure resource to coordinate those things?
Yeah, that's right. And there is an example in the DP100,
Right.
which I've seen, but I've just forgotten which lab it is. I was teaching this recently. Sometimes I teach this one. I will see if I can find it. Yeah, but there is one in one of the labs here. Talks specifically about that. I can't remember which one it is. I would have to look through.
Okay.
Sorry.
No problems. I can dive through there. Right. So I was tweeting away saying that at the end of your session, I'm going to stick on my CV that I'm an Azure ML guru. That in reality, how long would it take me before I could even dare to say that I was any kind of specialist in Azure ML? How much playing around would it take?
The way I look at it is I don't believe I can say that I know anything until I've got it in production.
Right.
Somewhere. So that's just one barometer. I mean, everyone is different. Some people feel that if they've got a certificate in something, then they know it. As you may know, I do some work with a charity called Datacoin, and we do data science for good, helping lots of charities. So to make the most of their data, And some of the work we do has been really, really fascinating. And one reason I love doing it is because it keeps my hands in with doing code. So I feel like I found my tribe, because people are just as passionate about doing social good exercises as I am. So just to give you one example, not using Azure ML, we used R for this and used open source technologies. We're working with a charity, which is a blood cancer charity in the UK. So we were using that to sort of look at donors in the stem cell register. So we did that. We also dealt with a women's refuge, trying to help them sort their data. And I managed to help them to sort out the data lineage, which may not sound very interesting, but the data lineage showed that a lot of the referrals to the Women's Aid Refuge were coming from the police. And when the police refer people like that to charities, the charity can sometimes be entitled to claim money back from the police, because the police are essentially referring someone to the service. Now, it's not much, but this charity had not been doing it at all. So by the end of it, of helping them that day, they were just elated and almost near tears, because they said with that sort of money we could do up our waiting room so that when a woman comes in, and her family usually, they are much more comfortable when they're sitting waiting to be seen. And that's such an important part of the process, is making people comfortable and happy when they are in those very difficult circumstances. So I think with that, the money they raise from that just helps buy a sofa. Now, it probably doesn't sound much, but it means a lot to the families and women that are there. Another piece of work I did was I did some work for one of the London councils, helping them to predict homelessness, who was most likely to become homeless. Now, that is a hugely important issue, given that the COVID situation at the moment is more likely to impact people who rent than people who are homeowners. So it's not like the 2008 financial crisis, which hit a lot of homeowners. The COVID virus is hitting people who don't have that. So looking at homelessness is actually really important. But you want to basically catch people before they fall. And the data is so interesting, because people think that of homeless people being the people they see in the street, you know, that are sleeping rough. But what we found was the largest group of homeless people by far are women and children who are victims of domestic violence usually, and they're by far the biggest group. So when they turn up at the women's refuge, at least they are slightly more comfortable for at least a little period of time. So yeah, so much you can do with data that's so good. But to answer your question, I tend to think I only know something if I've got it in production, and helping charities like Datacoin means that I can get stuff in production, and it's only then I feel I know it.
So how does somebody sign up to help out Datacoin then? Is it an easy process to do that?
Yeah, it's you can go and just sign up at the website. I think it's just datacoins.org or something, I can't remember.
Do you have to guarantee a dedicated amount of hours that you can offer, or how does that work?
No, you don't have to, and actually you don't even have to be a savvy data scientist. So one of the charities I was helping was actually the Anthony Nolan charity, and two women turned up and they said, we only know Excel, but we're here because you helped our family and we want to say thank you and we're so grateful. So even if you just turn up and make cups of tea all day, we just believe in what you're doing because you saved our nephew's life. And it's so humbling meeting them. And they were quite disparaging about themselves, because they said, we only know Excel. Yeah. But actually, their insights into the whole process of how the charity worked and how they could help better, or perhaps give them insights, and some of the questions, the business questions that they looked at in Excel, were just brilliant, because they had that expertise as being someone who'd used the charity. So for those of you listening, please don't think, oh my gosh, I have to be a data science expert. Everybody's learning, and we will be grateful for any time that you can give us.
Well, I've got wicked notepad skills, so when I have some time one day, maybe I can have a look and see what I can do.
Yes.
I've got final question here regarding you talked about writing in different languages, R and Python. I ask a lot of data scientists this question. I'm still not sure whether I've really had an answer that I'm happy with. Why would you choose R over Python or Python over R? Is that really something that somebody like myself needs to ask?
Well, I think that if you can learn one, you can learn the other, is my first thought. I get asked this a lot. I tend to think R is better for statistics and Python's better for crunching data. So when we come back to our machine learning here, this is just my thoughts on the matter. I tend to think Python sits better at the data preparation piece because it has some packages in there like pandas, which are very good for crunching awkward parts of data. And I tend to think R is a bit better at the modelling piece. I mean, the thing is that we're seeing other technologies coming out, like Azure ML, which has got, it can hook into some of the other Python libraries like scikit, which has got some fantastic modelling in it. So I think I don't think R's had its day, but I do think it is less popular at the moment. It feels like the planet is done R, ticked that box, and started to move into Python. So I think the reason Python is taken off is partly because I teach it in schools. So my son has been learning some Python, well, when he was at school, before the virus happened. So there's that. And I think also because Python fits in nicely with other languages like Visual Studio, R itself is more aimed at people, I guess, who are business intelligence experts who are comfortable with Excel. But if you're approaching it from the developer angle, probably Python sits better within your skill set. I think we'll get to the point, and we see this in Azure Machine Learning, where your data scientist builds your model, and basically they just give you allow the developer to make an API call to send data down and back up again. So you'll just have to write a couple of lines of code, which they give you actually when you deploy a model. And you should be able to see it in here. So I don't know if that helps.
Yeah, I think so. That definitely makes sense. I mean, I've used Python and pandas myself, and you're right, it is a lot easier to manipulate data. I say it's a lot easier. I haven't really done anything in R, so I can't really compare it, but it is easy to do manipulation in Python. Yeah, that does definitely help. So that's it for me in questions. I don't know whether have you got anything to wrap up? Did you run an experiment and
It did.
did it give us any results or not?
Let's have a look. I know, did it do anything? I'm not sure. Let's have a look. I was letting it run because it takes a little while sometimes.
Yeah.
All right, okay, so it's actually done something. So what we can do is we can look at evaluate model, and we can see the output over here. We can visualize that. And that can help us to understand and have a look at the data. So when I look at this, the numbers aren't looking very good. I'd have to get back and then probably change the model and see why it's come up with that. When we click on score model, this allows us to see whether it was right or not. So the income here, 50%, below or above 50%. So it's come up with the number here, the scored label, whether it is 0 and 1 will be where it will be. It's working at a probability basically. So it looks like this person, according to the model, doesn't earn above 50%, 50k, and that's exactly what that says. So there's that. And there's a lot less columns there than I'm expecting though. That's strange. I know, that's okay, I can have a play around with that. So we can see here when we split the data and we look at the visualizations here, many rows that we've got, so we get 22,000 in there. Now, it was the score model that's the most interesting piece really. That's where we try and determine how well did the model do. So I haven't run any experiment here really. We need to play around with it a bit more, but it just, the numbers for that aren't very good. So I want to play around with that. I could probably try a different model and see how that results. So the coefficient of determination looks really low. So it didn't predict very well. And linear regression is just basically where you take one variable and use that to predict another, like height and weight. So using one of the other ones would probably give us a better result. So I could just delete that and then try something like boosted decision and then run it again if I could connect it together. There we go. I'm such a plank. Let's see, how does that go? There we go. Submit. So then I can run that again and see how it goes. But you can see how easy it's been just to change models and try a different one. I've not had to write any code, it's just drag and drop. So I think that's one of the beauties of it really. It's a good way just to get started and see what happens really. It's not a linear process. It's fail fast, fail often, fail safe kind of project.
Thank you very much, Jen, for that. What I'm really looking forward to is watching a recording again, because this stuff does pickle my brain a little bit. I have to confess. I'm looking forward to going through your presentation again, and then maybe trying out the model with you at the same time. You might get lots of questions from me as I try that, though, so be prepared. So,
that's okay. Okay. It was my pleasure to talk to you. So anytime.
Yeah, it's been fantastic having you on. I really appreciate you joining us, and I look forward to seeing you all soon.